Number 7 gives us the expression 4x plus 6y equals 33, and we're told to solve for y. What that means is that we want to move everything in this problem so that all we have left is a y on one side of the equal sign. I'm going to do that by leaving the y in place and moving everything else away from it. So I'm going to start by moving this 4x to the other side. I chose the 4x first because it's connected by addition, whereas the 6 is connected to the y by multiplication. Order of operations says we should always undo addition or subtraction before we undo multiplication. I'm going to rewrite this problem as 6y equals 33 minus 4x. You can't combine the 33 and the minus 4x because they're not like terms. The last step to get y by itself is to undo the times 6 with a divide 6. Now when I divide 6 on the other side, since I have to divide everything by 6, I just do one big fraction bar with a 6. We're now left with y all by itself on one side of the equal sign, and this nasty looking fraction 33 minus 4x over 6. It doesn't look like a very good answer because it's not just one clean number, but the answers for these type of problems are usually something a little bit uglier like this. Number 8, solve and graph. Negative 3x plus 2 is less than or equal to 8. We pretend like this is an equal sign and we just solve the equation. We move the plus 2 over first, it becomes minus 2. So we find that negative 3x is equal to 8 minus 2, which is 6. Divide both sides by negative 3, and we're left with an x and a negative 2. Remember, anytime you divide by a negative in an inequality problem, you have to change the direction of the sign. So now instead of less than or equal to, I have a greater than or equal to sign. X is greater than or equal to negative 2. So we circle negative 2 on the number line. Because it's greater than or equal to, we color the dot in, and we shade the numbers on the greater than side of the number line, which is to the right. Number 9, solve and graph. We're given two inequalities. 2x plus 1 is greater than negative 7. 5x plus 1 is less than or equal to 16. We'll just solve them separately and then put the graphs together. First we subtract the 1 and find that 2x is greater than negative 7 minus 1, which is negative 8. Lastly, we divide by 2. We end up with x is greater than negative 4. This is one of the two pieces of information we need. If you want, you can put that on the number line right now. We circle the negative 4. Because it's greater than, we should leave it as an open circle. And let's just remember we're talking about x is greater than. So I like to draw a small arrow that points in the greater than direction. The next inequality to solve is the 5x plus 1 is less than or equal to 16. Subtract 1. 5x is less than or equal to 15. Divide by 5. X is less than or equal to 3. We find 3 on the number line and circle it. Because it's less than or equal to, we color it in, and less than is to the left. So the solutions on this number line are indicated by the shaded areas.